Yes, students, here we will go with the object with a numerical. An object of mass 1 kg traveling in a straight line with a velocity of 10 meter per second collides with an strikes to a stationary wooden block and sticks to a stationary wooden block mass 5 kg. Then they both moves together to the same straight line. Calculate the total momentum just before collision and total momentum after collision and the velocity of combined objects. Suppose if we are having this object which is having 1 kg mass which is moving with in this direction with a velocity of 10 meter per second, collides with this object, say it's collides with an strikes to a stationary wooden block and sticks. Okay, so here we are having this object which is having initial velocity 0. I can call it as u2 is equals to 0 and its mass is 5 kg which is given to us here. So momentum before collision, the sum of momentum, total momentum that we can say of these two objects. So 1 into 10 plus, it is at rest, so it is going to be 10 kilogram meter per second square, per second, not seconds. Then when it collides, it sticks with this, means both objects are moving with the same velocity. So we are assuming velocity v after collision. Velocity after collision, that is going to be v. Okay. So total momentum which we are getting after collision will be the sum of these two masses 1 plus 5 into the velocity. So it is going to be 6 into v. And this 6 into v is equal to this. This is the momentum which we can say before after collision, and this is before collision. And from law of conservation of momentum, we know that the momentum before collision is equal to the momentum after collision. So here we are having this 6 into v which is going to be equals to this 10. So we are getting v is equal to 10 upon 6 meter per second. This is the velocity which we are getting. Now both the objects will be moving with the same velocity, that is 10 upon 6 means it is 1.61 1.6 meter per second, that we can say. Okay. Now we have got this velocity. Now we can substitute here, so we will get the momentum, that is going to be here momentum P2, that is 6 into 10 upon 6 which is going to be 10 kilogram meter per second. Okay. Now next question, an object of mass 100 kg is accelerated uniformly from a velocity of 5 meter per second to 6 meter per second in 6 seconds. Calculate the initial and final momentum of the object and also find the magnitude of the force exerted on the object. Now here mass is given to us, that is 100 kg. Mass दिया हुआ है 100 kg. Velocity, initial velocity u is also given to you. Initial velocity, इसको हम initial velocity कहते हैं u, 5 meter per second. Final velocity, that is 6 meter per second in 6 seconds. Time is also given to us, 6 seconds. Now we can say initial momentum, that is pi, which is going to be m into u, which is 100 into 5, that is 500 kg meter per second. This is the initial momentum which we have got, and final momentum that we can say Pf, which is m into v, that is 100 into 6, which is going to be 600 kg meter per second. Now after getting these momentum, what we have to determine? Force exerted on the object. Now we know that change in momentum, that is Pf minus Pi and divided by the time. The time rate of change of momentum is going to give you the force. So it is 600 minus 500 divided by time, that is 6 seconds. Okay, so it is going to be 100 upon 6 Newton, means 50 upon 3, and it is nearly 16.6 Newton. This much force is exerted on the object. Okay, so we are going through the questions which are in the NCERT books. Okay. Here the student, here we are having a question: how much momentum will a dumbbell of mass 10 kg transfers to the floor if it falls from a height of 80 cm? That its downward acceleration 10 meter per second square. Now this bell is coming to this floor, so height is given to us 80 centimeter. It is initial velocity is 0, final velocity will be there. So if we go through this, v square is equal to u square plus 2s, that we know. So v square minus u square, which is going to be 2 into acceleration, that is 10 meter per second, and it is 80 divided by this. Okay, so it is going to be 16, and initial velocity is 0, therefore it is going to be v square, v is equals to 4 meter per second. Okay, so initial momentum which we are taking here, Pi, that is going to be 10 kg multiplied with 0, that is 0. Final momentum which we are going to have, mass, that is 10 kg, and this is going to be 40 kilogram meter per second. So the momentum which is transferred will be given by 40 kilogram meter per second. This is the momentum transferred. Because here we are having initial momentum 0 and final momentum, so final momentum minus initial momentum is going to be 40 kilogram meter per second.